without getting into the details, about how to enable the next set of services. And the focus would be on the Internet of Everything, or maybe the Internet of Things, depending on how you look at it, in integration with the cloud services, and we want to provide really intelligence everywhere. But before I get there, this is an interesting survey of the top IT jobs in 2014. And if you look at the top jobs in here, many of these jobs, if not maybe the vast majority, jobs did not even exist a few years ago. I believe this will even get, the development of new jobs will be even faster, will be growing at a faster pace. So for example, business architect, although you could argue, well, business architect has been around for a while. However, the function of business architect is moving from the IT department to the line of business. The budget actually is moving from the IT, from the huge IT infrastructure to the line of business, and they're letting the business units determine how they want to spend their IT budget. Hence, the impact on services. In other words, companies are more interested in the service itself rather than the IT infrastructure and the IT department. Data scientist is one of the biggest jobs right now. This is like the big data analytics type of position. Social networking engineer. The impact of social web tools and services impacting the businesses as a whole, all the way from the service you're selling into the infrastructure that you need to have in order to support such technology. And the same for social media analyst or architect. And what I'm describing here, this is not Facebook, Google type of social media, if you will. This is like companies like IBM building an entire suites for social networking and social business. The same way they have traditional verticals all the way from CRM into specific management systems. How do we do this to utilize the knowledge coming from the social networking as a whole? What you've seen with Facebook's and other social media is just the tip of the iceberg. Mobile technologies is another key area. And the focus there not only to control the devices coming to the company, as Deborah mentioned, but even how to utilize the mobile technology to full extent to impact services. I mean, for example, as you know, location, something we did not have before, now we have it with the mobile devices, scanning capabilities, and so on. Then cloud architect is another area, Internet of Everything, both architecture and engineering is another area in here. And the next slide, again, this is a survey in the Economics magazines from the top 800 executive survey. This was done, I think, December of last year. So they asked, well, top executives, when it comes to the Internet of Things in here, what are the obstacles of your organization of using the Internet of Things? Although many of whom believe it's a very important technology and they are moving in that direction. And as you could see, the top response and the top was the lack of employee skill or knowledge, engineering, architects, and so on. They know they need to move in this area, but the skills in this area is very important. So with that, let me just give a very high-level overview of the Internet of Everything, then describe the impact and services at the very high level in the 10 minutes I have. So the Internet of Everything is a new concept, basically everything connected to the Internet, all the way from people, cars, healthcare systems, home appliances, aircraft engines, and so on and so forth. Everything connected to the Internet. It's projected, this is the Cisco study, you've seen it, I think, published in many places, $14 trillion, the impact of this service, all the way from the new services and the changes of existing services into this new infrastructure between 2013 and 2022. Now, I believe, and I have a paper actually in hand that will appear in the IEEE Internet of Things Journal, the first one of the first issues. I believe the Internet of Everything will give birth to a service called maybe everything as a service. Right? I mean, you've seen all of these different phrases. So what does that mean, everything as a service? So for example, let's pick the driverless cars. So right now, many radio stations, I mean, they have, or TV stations, they have their own bands, their own equipment, and so on and so forth. If something happens, they send a reporter to the scene, and they cover everything, but everything, all the way from the cars to the cameras to the infrastructure, they own. But with this right now, let's say they hear there is an accident, major accident somewhere, then they could very quickly lease cars, driverless cars as a service, because they don't need drivers anymore, they don't need to send anybody over there. The cars then themselves will go to the site scene, and they start reporting the information, whether about the accident or the traffic broadcast information back. Or traffic lights could communicate with the vehicle, with approaching vehicles, as they sense people coming in, either walking or on their bikes, prevent accidents from happening. Smartphones, and we have some of these capabilities right now, you could argue, but the smartphones themselves become a mechanism, an Internet of Everything device, where they sense the environment around you, different type of sensing, all the way from congestions to chemical alerts and so on and so forth. If you have maybe specific health conditions, so they are in communication with your health scenarios, and they could alert you accordingly. And you may have seen a flavor of this slide, but this is really from Richmond Research, a slide about when you think about what is the Internet of Everything. It's a very comprehensive space, as you could see in here. All the way inside this are the areas, the different service sectors impacted. So what I'm like on the right-hand side, inside, all the way inside, there is a huge vertical in the IT networks, another one in security and building safety, a third one in retail, then transportation, industrial, healthcare and life science, consumers and home, energy management, and building management. Each of which, let's focus on the IT, the one on the right-hand side, all the way on the top, for example. They have different application groups. So IT, you have public and enterprise type of applications. Then you have different locations to manage IT and networks as part of the Internet of Things. So for example, you have services, e-commerce, data centers, mobile carriers, and so on. Then you have the devices that make up the infrastructure of that service. So for example, the servers, the routers, the storage devices, the printers, the PCs, and so on and so forth. So each of these verticals, the challenge right now, have a specific set of standards and environment, and even within each of these verticals, there's no standardized way of achieving the solution. The reason I put up this slide, at the end we are focusing on the service itself. We want to deliver a service as economically and as cheap as possible, and that's really the concept of the Internet of Everything. By the way, you could argue the Internet of Things or the Internet of Everything is not new. For example, jet engines have been communicating back with different data centers. However, the communication has been extremely expensive, often over satellite communications, and they're not utilizing the cloud technology, they're not utilizing the economical way of doing the communications. Hence, moving to an economical framework is the most important part in here, in this solution, and hopefully in a consistent fashion. So as you could see in here, without getting into the detail, in order to understand the services or the potential of services that the Internet of Everything could offer, you need to understand the infrastructure, the hardware that is, the network, how these devices are communicating together, the intelligence or the software that putting everything together, including the solution integrators and the partners and customers, then come up with the best set of devices. So in the last couple of slides, I just want to give you an idea about how to enable Internet of Things through cloud services. Now, the core requirement of the Internet of Things, as of many technologies, is really sensing the information. Without having the capability of sensing or acquiring the data, you don't have anything basically to build on top of it. So the most important thing is sensing the information or capture the relevant data. You want to capture this as cheaply as possible, hence where IP comes in. You want to structure the data after you, or parse the data after you capture it. You want to analyze it. Hopefully you want to analyze it. Some of the data should be analyzed close to the source, like if you're doing diagnostic analysis to make a decision very quickly. Most of it will be sent to the cloud to do a global analysis by interacting with different applications in the cloud. And then from which, based on this knowledge, after you capture this, now you could adjust the service you have. So for example, if you are an IT department, you want to adjust the service level agreement, or you want to make sure you meet the service level agreement by adjusting different variables you have in your network, or the quality of service, or the grade of service, which means the end-to-end of the service. And you could use all of this data to predict impact on the service itself. You could offer new services, you could enhance services, and use it in that fashion. So for example, if you have you have a way of achieving all of that information, you could determine basically, let's say you have a product, and the product offers maybe 200 type of services. You could determine which service is used the most, which service is used the least, the sequence, how customers are using the service. So if they're maybe doing 3 steps in order to achieve the same thing, and many are doing this, maybe you need to combine these 3 steps into a single step. And many companies are doing this already. Now, what's the difference in here? Now, with the recent successes in the cloud computing, given the cloud services are being offered right now, all the way from the infrastructure into the platform, into the software as a service, with the mobility, you could combine all of these capabilities together and start achieving the capabilities of acquiring the information, analyzing the information, and make decision in the right fashion. So, for instance, in order to use the cloud, you need no longer to really have an agent in the network, assuming the network is the service in here, in order to capture this information. You could use the cloud. You could use a virtual collection systems, if you will, or a virtual sensing capabilities in order to collect the information you need. Now you could store and process the information in the cloud. You could analyze the information locally or globally. Non-real data should be analyzed globally. Now you could interact with the different business intelligence or business analytical systems you have. And you could make the results available to different customers over the cloud very quickly, either the customers or the network administrator or whoever is managing the service. And the elastic provisioning is very important as part of the cloud right now. You can scale up and down very quickly. So in other words, services are moving into the utility model. None of us have generators in their homes to generate power. You buy the powers as a service, but the reason you do that because you could count, you know it's reliable, you know you have that service all the time. Whereas if you don't have that capabilities, then you need to buy your infrastructure, and we're moving into a utility model, and that's really the important point in here. The last slide I have in here is basically what I just summarized in the previous slide. So all the way, you have the infrastructure, this different type of sensors, the equipment, the data centers, and so on. Then you need to sense that information, collect the information. Then in the middle, you have the platform, which basically need adapter to sense different type of information, including the capability of big data. If the data coming in is considered big data, you need asset management, which is the core of everything you've got to start with. Then once you have the asset management, now you could do global analytics, for example, across the fault, configuration, accounting, performance, and security. And you could do trending analysis and find out what type of services you have to offer. And you do all of this by integrating with the applications layer on the top. Now, the last thing I'd like to say, many companies, Google, for example, with their recent acquisition of companies in here all the way in the sensor side. And then there are the applications all the way up with the different companies. The missing part is really the platform. There's still no comprehensive platform that connects the infrastructures with the applications. And I believe you will see many of the acquisitions in this area. The platform basically taking the information all the way from the sensors, like Google with Nest, for example, and communicating different protocols and different type of measurements all the way into the applications and the cloud, and make this happen as quickly as possible. So with that, I conclude. Thank you very much.